ओके, मेरी आवाज आ रही है? ओके, मेरी आवाज आ रही है ना? गुड। जरा कैमरा ऑन करो फिर। कैमरा ऑन, कैमरा ऑन, कैमरा ऑन। So let me share। तो मैं कह रहा था ओपन मैपिंग थ्योरम से हम प्रूव कर सकते हैं दैट द जो ये लाप्लास ट्रांसफॉर्म है एज अ बाउंडेड लीनियर ऑपरेटर फ्रॉम द कलेक्शन ऑफ इंटीग्रेबल फंक्शंस ओवर 0 to infinity to the continuous functions is not on, it's not subjective. Laplace transform since me converts a function into another function, and formula for conversion is, the formula for conversion is LF evaluated at S is equal to the integral 0 to infinity e raised to power minus st ft dt. So if I take my function f belonging to L1 over integrable functions and measurable functions that are integral in mod in this range 0 to infinity, then LF जो है ये function resulting function है, it belongs to C 0 infinity, the continuous function on 0 1. So it is obviously a linear operator, right? Before that, let's do a little lemma जिसको हम use करेंगे as a theorem इसको करते हैं. Suppose T is a surjective bounded. Suppose T is a surjective bounded a linear map between Banach spaces. Now, in case T is 1, 1, which is obvious, then T inverse be continuous. That's obvious rather. T inverse is also linear and continuous. B, norm of T whole inverse is less than equal to norm of T inverse. C, norm of T inverse into norm of X is less than equal to norm of T of X, which of course is less than equal to norm of T into norm of X, because this is a bounded linear operator. So proof पहला तो बिल्कुल simple है. Now T inverse is a map from Y to X. क्योंकि मैं कह रहा हूँ T is 1 1 surjective भी है, तो T inverse exists from Y to X because T is a map from X to X between Banach space यहाँ लिखना है X and this one. Okay, so it's a linear map between Banach, तो T inverse exists करेगा अगर ये 1 1 भी है साथ में, and that would be a map from Y to X. So T inverse, and how about T inverse ka inverse of O is the same thing as, what would be this T inverse ka inverse to T hoga, so it is T of O, right, is open whenever O is open in X. Why? Because by overmapping theory. Which implies that T inverse is continuous. Linear तो है ही, because inverse of a linear map is linear. If it inverse exists, of course. B. Now let y belong to y, then norm of y can be written as, क्योंकि inverse exists करता है, it can be written as T composition T inverse of y, which is less than or equal to, because T is a boundary linear operator, norm of T into norm of T inverse into norm of y, क्योंकि ये दोनों ही boundary linear operators हैं. So which would imply T inverse को यहाँ लाते हैं, which would imply that, what would it imply? So it would imply that norm of T inverse, इस तरह से T इसको यहाँ लाते हैं, into norm of y is less than equal to norm of T का inverse into norm of y, ये cancel हो जाएगा, तो दूसरा पार्ट हमें मिल गया, norm of T inverse is less than equal to T inverse का norm. थर्ड पार्ट भी ऐसा ही है, it's nothing. Now C में भी बिल्कुल ऐसा ही होगा, यानी you would have what norm of x को हम अब लिखेंगे ऐसे, इसको मैं लिखूंगा norm of T inverse of T of x, which would be less than equal to norm of T inverse into norm of T of x, which implies that ये यहाँ पे x है, which is further वही less than equal to norm of वही जो इससे पहले था, into norm of T into norm of x, इसको cancel कर दो, so you will get what? Norm of T inverse का whole inverse is also less than equal to norm of T. मतलब इसी का dual नहीं, मतलब वही बात है. Okay, we show that चलो ऐसे लिखते हैं, the Laplace transform, लिखते हैं कैसे लिखें, Laplace transform, अगर मैं इसकी डोमेन को restrict करता हूँ, of course to the continuous functions, L defined by LF at S, actually this is true for any complex S, मुझे हमेशा लगता है you should write it like this, although ऐसे भी लिखते हैं books, but this should be L of F applied at, evaluated at S is equal to 0 to infinity e raised to power minus st ft dt s greater than or equal to 0 is a linear operator. Linear to obvious है, from, because integrals are linear, from the Banach space L1, ऐसे लिखते हैं, L ऊपर लिखते हैं, नीचे हम वैसे नीचे लिखते हैं, 0 infinity to C 0 infinity, continuous functions on this interval. Linear तो तुम देख ही सकते हो, if you take L of f1 plus f2 evaluated at S, क्योंकि तो यहाँ पे तुम्हें आ जाएगा f1 plus f2 evaluated at t. So since you can then break them into f1 of t plus f2 of t and break the integral into 2, so that's obviously linear. It's a linear operator. And L1 f at S, अगर मैं इसका modulus evaluate करूं, so it should be L, मैं क्या लिख रहा हूं, L of f, मैं इसको ऐसे बोल के लिखना, L of f evaluated at s in mod would be equal to 0 to infinity e raised power minus st ft dt in modulus, which would be less than equal to 0 to infinity. I should write e raised power minus st क्योंकि ये हमेशा नॉन नेगेटिव होगा, so इसलिए मैं यहाँ ft लगा देता हूँ dt, which is clearly less than equal to integral 0 to infinity mod ft dt. Why? How should I see? You can see अब मेरे पास s is greater than equal to 0, t is also greater than equal to 0, so they are non-negative, therefore इनका product non-negative है, और अगर product non-negative है तो e raised to power st जो है वो greater than equal to 1, because this is an increasing function, right? And chunki this would be greater than equal to actually e raised power 0, which is equal to 1, which means e raised power minus st would be equal to 1 by e raised power st. This is always less than equal to 1 if the power is non-negative. So this is less than equal to 1, तो हम इसका maximum लेंगे, that's equal to 1, so मतलब वही हमने किया, whatever, so that's it. So this is equal to norm of f1, so which means that if I now take supremum क्या लेना है, it means norm of this L of f, क्योंकि ये हर एक के लिए है, और अगर मैं मतलब it's for any s, so it means अगर मैं लूंगा supremum over this domain, so this would be less than or equal to, तो इसका sup norm है because it is a continuous function, so this would be less than equal to norm f1, which means that L है is continuous, it's a bounded linear operator, and of course here we can norm of this operator is less than equal to 1. That's because this is the infimum, this is defined infimum of these numbers that fit here, that fit here in this position, I mean to say. Okay, now what we do, now we show that L is not onto. Now assume that L is onto. L is onto, right? अगर L onto है, then L inverse would be continuous. L inverse will also be continuous, will also be a bounded linear operator, and by open mapping theorem, it would imply that C norm F1 is less than equal to norm, it will be bounded below anyway. बात एक ही है, मतलब अगर तुम थोड़ा सा इसको सोचोगे, for some, I should write there exists a C. चलो. So that implies that there exists a C positive such that C times norm F1 is less than equal to, ये मतलब है इसके inverse के continuous होने का as a bounded linear operator for all f belonging to L1 0 infinity. मतलब Lebesgue integrable functions that are measurable and जो है हमारी definition इसकी. So let's call this star. अब हम दिखाएंगे that this would lead to a contradiction. So उसके लिए हम कोई particular function लेंगे. Let's see कौन सी लेंगे. Okay. Now consider, let n be any natural number and define fn as a function to the characteristic function of n plus 1 semi-open interval minus characteristic function of n plus 1 to n plus 2. मतलब ये मैंने fn को डिफाइन किया, राइट? सो देन पहले तो ये कि नॉर्म ऑफ fn जो है 1 जो है, मतलब इंटीग्रल नॉर्म दिस वुड बी इक्वल टू 2. यानी मेरे कहने का मतलब है अगर मैं इसको इंटीग्रेट करता हूं फ्रॉम 0 टू इंफिनिटी, राइट, इसका जो मॉडुलस है इंटीग्रेशन में, यानी अगर मैं लेता हूं काई n plus 1 minus chi of n plus 1 comma n plus 2, of course evaluated at t in this range dt. And as you can see, if I break this into, ये तो मैं समझ ही गया हूं, जो n से 0 से n तक तो ये 0 होगा, है ना? एक्चुअली मुझे सिर्फ देखना है, मैं इसको लिख सकता हूँ ना, इंटीग्रल को पैक करूंगा मैं 0 to n, फिर मैं लूंगा n to n plus 1, फिर इसको मैं ब्रेक कर सकता हूँ n plus 1 to n plus 2, फिर मैं ब्रेक कर सकता हूँ n plus 2 to infinity. अब ये पोर्शन होगा इंटीग्रल का, राइट? क्योंकि कैरेक्टरिस्टिक फंक्शन इन सेट से बाहर तो 0 होगा, दिस वुड बी 0 minus 0, ये भी होगा 0 minus 0. और इनमें क्या होगा, अगर x n to n plus 1 में करता है, so this would be 1 minus 0 in mod. और ये क्या होगा यहाँ पर होगा अगेन, जब इस इंटीग्रल में होगी तो इट वुड बी, ये तो 0 हो जाएगा, so it would be 0 minus 1 dt. So as you can see, finally this would be n to n plus 1 integrated 1 from इसे plus n plus 1 into n plus 2 1 dt. Or फिर actually I can write from n to n plus 2. So obviously none of this is just 2, right? जो ना इसका norm होगा, norm of f1 is equal to this thing which is equal to 2. Now this is true for all n belonging to the natural numbers. Moreover, I want to evaluate now its Laplace transform of this function. वैल्यू तो ये है कि ये लाई करती है हमारी डोमेन ऑफ इंटीग्रेबल फंक्शंस में. इनफैक्ट इसका इंटीग्रल इज एक्जैक्टली इक्वल टू 2 फॉर ऑल n. Furthermore, if I want to evaluate its Laplace integral, LFN evaluated at s, this would be 0 to infinity, जो भी है अपना e raised power minus st into fn d dt, that would be equal to 0 to infinity e raised to power minus st chi n to n plus 1 evaluated at t minus chi of n plus 1, ये यहाँ semi open है, I want to keep them disjoint. Okay, evaluated at t ऐसा होगा dt, and as you can see this would be 0 to infinity e raised power minus st chi at t using the property of this integral dt minus integral 0 to infinity, same thing, but our characteristic function is of n plus 1 n plus 2. Now as you can see, ये हर जगह 0 है सिवाय इस इंटरवल के जहां पे ये 1 है. So this should be n into n plus 1 e raised power minus st dt, and here हमें मिलना चाहिए n plus 1 to n plus 2 e raised power st dt, and हम इसको इवैल्यूएट कर सकते हैं. So that is e raised to power minus st divided by minus s evaluated from n to n plus 1 minus e raised power minus st divided by minus s, right, evaluated from n plus 1 to n plus 2. So this would be, I can write it as e raised power minus s into n plus 1 minus e raised power minus s to n minus e raised power minus s n plus 1, or plus, of course, minus minus plus e raised to power minus s into n plus 2 आना चाहिए, n plus 2 upper value. Then I have the lower value n plus 1. That's good. ये cancel तो नहीं होगा. Okay, divided by minus s, जिसको हम लिख सकते हैं e raised to power minus ns को मैं कॉमन निकालूंगा. यहाँ आना चाहिए e raised to power minus s. Then I should have minus 1. Then I should have minus e raised to power minus 2s. Then I should have plus e raised to power minus s. So divided by minus s, now that would be s भी कॉमन ला सकते हैं हम. राइट, तो अगर मैं इसको ऐसे लिखूं, पहले इस s को खत्म करते हैं, यहाँ s लगाते हैं, e raised to power minus s, अंदर बचेगा, मैं ऐसे लिखूंगा e raised power minus s को माइनस कर देते हैं, इसको प्लस कर देंगे, minus 2 raised to power e raised to power minus s and plus 1. मैंने माइनस को एडजस्ट कर लिया और नीचे आएगा s स्क्वायर. So that is, चलो अभी मैं यहाँ पे लिखता हूँ, Laplace transform of this function evaluated at s should be s into e raised power minus s ns into e raised power minus s minus 1 divided by s ka whole square. So we are done. Now what we do, so we show that, what we show that is that, now चलो मैं लिख देता हूँ, maximum of e raised to power minus s, e raised to power minus s minus 1 divided by s का square जो है is 1 on s belonging to 0 to infinity, and the maximum of this thing, and the maximum of this thing क्या है अपना, s into e raised to power minus s is 1 by ne. So उसके बाद क्या, उसके बाद so that thus we will get, अगर मैं पीछे जाऊं, इसको हम दिखा, मतलब ये तुम थोड़ा होम असाइनमेंट है तुम्हारा, वैसे इजी है ये दिखाना, इट्स जस्ट यूजिंग कैलकुलस जो हम करते हैं, डेरिवेटिव्स वगैरह. तो so by this star it would mean c times, it means twice by star, चलो लिख देते हैं, then by star twice c would be less than or equal to, मैंने क्या लिखा, twice star is less than or equal to 1 by ne for all n. Now, since n is arbitrary, we get, this is a contradiction, huh? This is a contradiction. Why? You cannot have a positive number that is less than 1 by ne for all n, because this can be made arbitrarily small, but this will go arbitrarily to 0. You cannot, this cannot stay positive, since c is supposed to be a positive number. So therefore this cannot be subjective, L cannot be subjective. अब इसमें एक ही चीज है, वो मैक्सिमम बताना, तो वो तुम आराम से कर सकते हो, मैं तुम पे छोड़ देता हूँ. शो दैट दिस, ये जो दो है होम असाइनमेंट, जस्ट यूज कैलकुलस, जस्ट करते हो ना, डिफरेंशिएशन से मैक्सिमम मिनिमम ढूंढते हो, तो इसका मैक्सिमम मिनिमम भी ढूंढो इस इंटरवल पे, सो यू वुड बी, इट विल बी डन. So that is how we can use, we used actually open mapping theorem that this L जो Laplace transform है, it cannot be a surjective map, although it is one-to-one. I think it should be, no, I doubt it would be one-to-one, क्योंकि हमने जो function space ली है, one-one तो शायद नहीं होगा, लेकिन on to नहीं होगा ये हमने prove किया. Although it is one-one from Laplace transform can also be defined from this L201, लेकिन फिर हमें एक और ऑपरेशन लेना है ना यहाँ पे. It has a, let me have you heard of convolution of two functions? तो अगर तुमने वो किया है तो वहां पे Laplace transform preserves that convolution. You have actually, चलो उसको रहने देते हैं. नहीं, Laplace transform of the convolution is the product of the Laplace transforms. So, but nevertheless हमें उसके साथ कुछ नहीं. यहाँ पे हमने दिखा दिया that it's not surjective. It cannot be surjective using open mapping theorem. Now another thing जो हमें करना है इसमें, वो हम करेंगे कल. रेडॉन निकोडियम थोड़ा इससे लंबा है. Okay, let me end it here. Just end it here. Yeah, it's 20.